radicals. To add or subtract two radical terms, they must be like terms. In other words, radicands must be the same. From your ed puzzle yesterday, what is a radicand? The expression underneath the radical. Okay, you did a good job on the ed puzzle. The radicand must be the same. If the radicands are not the same, see if you can simplify the radicand until they're the same. Then what you do is you treat them like a variable where you just add the like radicals. I think you're going to like this because it's fairly simple. So in example 1, 4 square root 5 plus 6 square root 5. Are the radicals the same? Yes. So then all you do is add the coefficients. This is so simple. Example 2, 2 square root 10x minus 8 square root 10x. Are the radicals the same? Yes. It's just negative 6 radical 10x. Example 3, do I have like radicals? No, I do not. So what we're going to do is we're going to simplify each one. So what I had in the ed puzzle for you was that, excuse me, you want to take out the largest perfect square factor. So this is going to be the square root of 9 times the square root of 6. And this is the square root of 4 times the square root of 6. So this is 3 square root 6 plus 2 times 2 square root 6. Then you do multiply the numbers out front. And I am truly making this percentage up, but I would say 99% of the time, the radicals should be the same. If they're not, it could be that they're just not, and we will see one today, but you probably made a mistake. All right, I'm going to pause a moment, and I want to give you a quick head start on me with example 4. Now, do you notice square root 10 isn't going to simplify, right? Square root 10 does not simplify. It's just 2 times 5. So sometimes it's like you have a clue. The common like radical is going to be a square root 10. So you want to look for the clues. So that's going to be the square root 4 times the square root 10. So that's 2 square root 10 minus 14 square root 10. That's negative 12 square root 10. I love math. Of course, that's why I'm a math teacher. But I think if you can look at it as you're solving a mystery or a puzzle, you can make this really fun. Like it can be a lot of fun to figure it out. All right, questions on example 4. All right, let me give you a head start. Do example 5 if you're a fast worker. Move on to example 6. Let's see if we can do it. Because you've got all the tools in your math tool belt to figure it out. So when I look at example 5, I notice at the end of the problem, 6 square root 2 square root 2 doesn't simplify. So there's a high probability 18 and 50 are going to be left with a square root 2. Does that make sense? So like you're looking for little clues that are going to help you do the problem. So if I'm going to want a 2, then hey, 18 is 9 times 2. 50 is 25 times 2. So I'm using the clues that the problem is giving me. So that's 5 times 3 square root 2 plus 2 times 5 square root 2 plus 6 square root 2. Now I've taught a very, very long time, and a common mistake I see is students, like they do incorrect math and they don't write the 5 down and they think I'm going to put it back in. So number one, it's wrong because the line above has to be equivalent to the line below. 2, you have to remember that that is 5 times 3. The most common mistake is the 5 gets dropped because they think, oh, I'm going to just do the 18 and then come back to it, and then they don't come back to it. So I'm trying to give you some advice here as to what I've seen over the years so that you don't make those same mistakes. So then if, whoops, thankfully I double check my work. I don't know why I made that plus sign. So 5 plus 6, that's 11 square root 2. Give me thumbs up. Did we get it? Yes. You guys are rocking the house. All right, in example 6, I have a square root 72 and a square root 8. Now, in 72, I can get an 8, but see, 8 is not simplified. So I don't want to go with 8. Let me say that again. Just because I can get them both to have a square root 8, it's not simplified. So it is assumed that all radicals will be simplified, okay? So this is going to be 4 times, and do you remember in the Ed puzzle, there's a upper level theorem in math that says when you're simplifying a square root, whatever n is, the number underneath, you want to try up to n divided by 2. So I'm going to take 72 divided by 2 is 36, and yay, that goes in. So like I'm giving you advice that will make your life easier. So this is 4 times 6 square root 2 plus 7 times 2 square root 2. And I got 38 square root 2. Now we have the product rule, which I mentioned yesterday. It is really important, and you don't know this yet, we're going to be getting into something called imaginary numbers in Unit 5. And so in order for the product property to work, when we hit negatives underneath, the product rule doesn't work if they're negative. Okay, so this product rule only works if the radicands are positive numbers, okay? And so the square root of a times the square root of b equals the square root of a times b. So in example 7, I can multiply those and say the square root of 100, which is 10. In example 8, this is the square root of 49, which is 7. In example 9, 13 times 13 is 169, and that's a perfect square. So it's just 13. Before we do example 10, 8 and 9 go together. What could you say about taking the square root of x times the square root of x? It's always the same thing. What is it? X. So square root 13 times square root 13 is the number 13. Square root 7 times square root 7 is the number 7. If you'll remember this generalization, it's going to make your life easier, okay? All right, now let's go on to example 10. I have the square root of 18. That's the square root of 9 times the square root of 2, which is 3 square root 2. Well, the product rule works for variables as long as the variables represent positive numbers. So this is going to be the square root of x to the 5th. Well, what you want to do, and we did this yesterday, this you want to take, because it's an even root, you want to take the highest even number in. So if it's even, it's done, but x to the 5th. And then one of the questions I asked, and we didn't do so well on it on the ed puzzle, is what is the square root to a fractional exponent? 1/2, right? The square root is the 1/2 power. So this is x to the 4th to the 1/2, and then you multiply the powers. And so there's a shortcut. Just take the even power and divide by 2. That's the same as multiplying by 1/2. So the square root of x to the 5th simplifies to x squared times the square root x. All right, example 12. I'm going to go ahead and multiply these and get 16x to the 6th, y to the 4th. And let me just remind you of this algebra 1 exponent property. A to the m times a to the n equals a to the m plus n. Now, I've gone over this formula with you at least 5 times this year. So, if you're still sitting there saying, gosh, I didn't know I was supposed to add them, this is now on you. I need you to take some action step that's going to help you remember this one, because we're going to keep using it and keep using it. And you're going to use it through pre-calculus, and if you go on to calculus eventually, you'll use it there as well. All right, so this is 4x cubed y squared. Square root of 16 is 4, and then when you have a square root, you just divide the variable exponent by 2. All right, let's look at example 13. You multiply the numbers out front, and you multiply the numbers underneath. I want you to think of the square root as a jail that you can't go from the outside to the inside, okay? Now, I need to simplify. The square root of 50 is 25 times 2. So that's 30 square root 2. All right, I'm going to pause a moment, and I want you to try example 14. Please don't work ahead because they're a different type of problem. But go ahead and try example 14. So I'm going to use the product rule. 12 times 6 is 72. I'm going to get x to the 8th and y to the 5th. Now what I do is I then split it back into perfect squares and non-perfect square numbers. We've already seen square root 72 before, and that's kind of nice, as the more problems we do, then you've pretty much seen them all, okay? So this is going to be square root 36 x to the 8th, y to the 4th, times the square root of 2y. Let me explain what I've done here. I like to put my perfect squares in the first one because they're going to come out. So I know 72 divided by 2 is 36, and that's a perfect square. So 36 times, and then the 2 goes in the right one. x to the 8th is even, so it's going to stay in my perfect square radical. And then y to the 5th, I want the highest even power, and that's y to the 4th. And in this review, we're going to assume our variables are positive numbers. Okay, we're not going to deal with the possibility that they're negative. So then my final answer is 6x to the 4th, y squared, square root 2y. In example 15, I'm going to use the distributive property. I'm going to make that the square root of 3 times the square root of 5 plus the square root 3 times the square root 2. These are not like radicals, and there's no simplifying to make them like radicals. So I mentioned that previously. If they don't add, they don't add, and that's as far as you go. There's no math property that says the square root of 15 plus the square root of 6 is the square root 21. That's like a big false. Like, think about that. Let's do a test. And we're going to do a non-example. If I said square root 4 plus square root 4 is square root 8, 2 plus 2 is not. Do you see that? Like, there's my counter example. It's not true. So don't do that. All right, in example 16, I'm going to FOIL. I'm going to take 1 times 4 is 4. The outer is 3 square root 7. The inner is minus 4 square root 7. Minus, what's square root 7 times square root 7? 7. So I'm going to get 3 times 7. Remember, we went over this right up here with example 8 and 9. Square root 7 times square root 7 is a 7. You need to remember that. So then this is 4 minus square root 7 minus 21. That's negative 17 minus square root 7. All right, in example 17, if I take a quantity squared, what does that mean? Multiply it times itself. So I'm going to pause a moment, and I want you to FOIL it. And go ahead, if you're a fast worker, go on to example 18. All right, so here we go. 5 times 5 is 25. The outer is 5 square root x plus 5 square root x. And what's square root x times square root x? X. This is 25 plus 10 square root x plus x. Do you see that that's not 25 plus x? Like, there is an outer and an inner term. Then example 18, I'm going to FOIL again. 4 times 4 is 16. The outer is minus 4 square root 3. The inner is 4 square root 3 minus, what's square root 3 times square root 3? 3. That's 13. Oh, what happened to the outer and the inner? They cancel. And do you remember when we were multiplying, like x plus 5 times x minus 5, and the outer and the inner canceled? Same thing. This is going to come in handy when we do chapter 5 on quadratics.